Good day, everyone. I am here to talk about basic integration. So, our objectives for today is to learn and apply the different integration formulas. So, defining integration. So, we have here I is for integration. So, I here is equals to the integral of the function of x times dx. Oh wait, sige. Function of x times dx. The function of x here can be an algebraic function, can be exponential function, can be logarithmic function, can be trigonometric function, and can be um, many more functions to be discussed. So, so we have here the two types of integrals. The first type of integral is our indefinite integral. Okay, cute. So we have our indefinite integral, which is the integral of the function of x times dx. So the next type is our definite integrals. Uh, definite. So this is um the integral with the integral from limits a. This is our first limit, which is a to b, with the times the function of x uh, times dx. So these are the two types of uh, integrals. So we'll discuss about algebraic. Uh, we will discuss about the integral formula under algebraic functions. So first we have um, the integral of 0 times dx. So um, the integral of 0 is equals to 0. And then we have our arbitrary constant, which is c. So we put here c. So integral of 0 times dx equals to c. So next is we have the integral of a times dx. So our a here is our constant. So according to the rule, we factor out a first, the constant first. So put a outside and then copy the remaining. So we have here. Um, then next we're gonna integrate um dx. So the integration is opposite of differentiation. So the integral sign here and the d here will be cancelled out. So the remaining will be x. This will become a times x plus our arbitrary constant. So we'll put the arbitrary constant after we integrate um, the terms inside our integral sign. So that is the rule of integrating. So our third formula here, we have square root of a x times dx. So wait, just like the previous example, we will factor out a and then copy the remaining terms. So we have here a times the integral of x times dx. So the integral of x is, we copy a, the integral of x is x squared over 2, then add our c, our arbitrary constant. And then the next example we have is the integral of ax squared. Ax squared times dx. So just like um wait, why we squared the x here? Because our exponent here is 1. So take note now. So here, since our wait, we factor out first, then put x squared dx. So since it has 2 exponent as the exponent, we will add it by 1. So plus 1 will round 3. Then divide it by 3 um, plus c. So as you can see, there is a pattern. We will know that in our next example. So for our final example, we have here um, a times the integral, the integral of a x raised ano man yun? A x raised to n times dx. So um so our first step is to factor out the constant. So we factor out a here first, and then put a x raised to n times dx. So since n here represents the number of exponent, so by integrating x raised to n, we have um, x raised to n. As you can see, our exponent will be added by 1. Okay, so come plus 1, and then we will divide it. I mean, we will divide this term by the number of the exponent. So we put here n plus 1, then put our arbitrary constant. So this is our um, formula, or should I say our power formula. Okay. So next we will go to our example. So our first example here, we have 5x 5x cubed 5x cubed times dx. Wait, the integral gali. Integral of 5x cubed dx. So according to our formula, first we're gonna factor out the constant, which is our 5, which is 5 gali, times the integral of x cubed. Copy x cubed times dx. So we have here the integral of x cubed, which is we will add 1 to our exponent and then divide it with the total exponent. So we have x raised to 4 over 4 plus our arbitrary constant. So we can simplify this um, term. So it will become 5 fourths x raised to 4 plus c. So now this is our final answer for our example number 1. So in the next example, we have 4 over x to the fourth power dx. So here, uh, since we have the exponent in the denominator, we have the term with the exponent in our denominator, we will put our denominator to the numerator. So our our rule here, when putting the denominator into the numerator, uh, our exponent will become negative. So we have here 4 times x raised to negative 4 times dx. So we can compute this. So first factor out 4 integral of x raised to negative 4 dx. So wait, so 4, then the integral of x minus x raised to negative 4, we'll just add 1, it will become negative 3. So x raised to negative 3 over negative 3. And then put our arbitrary constant, which is c. So we can simplify this. It will become negative 4 thirds x raised to negative 3 plus c. So this is your final answer. For next, for example number 3, we have the integral of 21x raised to 7 fourths dx. So we have here a fraction as our exponent. So like the other examples, we will factor out 21 first, which is our constant, and then copy the remaining term, which is x raised to 7 fourths times dx. And then we're gonna add 1 to our exponent. So since this is in fraction form, um, we will add 1. So by adding 4 over 4, this is also equals to 1, with the same exponent, with the same denominator as our exponent here. So by adding that, we have 7 fourths, and then we have um, 7 plus 4 is 11 over 4, because it has the same exponent. So by adding 1 to the exponent, we will have 21 x raised to 11 fourths over 11 fourths. Pero ay 1 ko. 11 fourths plus c. So now we will simplify this. We will transpose it in the numerator. We will put it in our numerator. So we'll have 21 times 4 over 11, like that. Then copy x raised to 11 over 4 plus c. So by simplifying it further, um, we have uh, 84. Uh, no, 21 times 4 over 11. Yes, 84 over 11. Then copy x 11 over 4 plus c. So this is now our final answer for the third example. So next, we will discuss about basic integration formulas under logarithmic functions. So our objective here is to know and apply the logarithmic uh, the basic integration formulas under logarithmic functions. So first, we will recall. So uh, the derivative of ln x, which respect to dx, is simply equals to 1 over x. So differentiation is opposite of integration. So when integrating, we have here 1, we have here integral of a over x is equals to, so And integrating, first take out the constant, which is a, and then we'll have 1 over x. So the integral of 1 over x is simply ln of x. So we have here a times ln of x plus c, or absolute value of x. So this is the absolute value sign. So this is now our formula for this topic, which is the logarithmic functions. So um, so we will discuss now the examples. So for example number one, we have for the we have ano naman? We have the integral of 4x plus 4x squared plus x minus 7 over x times dx. So we will integrate it term by term. So the integral of 4x squared is simply 4 thirds x raised to 3. Next, integral of x is simply x squared over 2. And now we have the integral of 7x. So the integral of it, put we will factor out the constant, which is the 7. Then the integral of 1 over x is ln x. So this will become ln times absolute value of x plus c. Wait, I forgot to simplify this. Sige na lang. So this will become copy 4 thirds. By simplifying it, 4 thirds x raised to 3 plus 1 half x raised to 2 minus 7 times the ln absolute value of x, and then plus our arbitrary constant. Then we have our final answer. So next, for example number 2, we have the integral of 2 over x plus 1 times dx. So again, we will take out our constant, which is 2. So 2 here times 1 over x plus 1 times dx. So copy 2, and then 1 plus x, 1 over x plus 1 is, the integral of it is simply ln of x. So we have here times the integral, which is ln. So x plus 1 will have the we will have um the integral, we will have the ln of absolute value of x plus 1, and then plus our arbitrary constant, which is c. So this is now your final answer. Next, for the third example, we have the integral of square root of x minus 1 plus 1 over square root of x plus 2 minus 1 over x minus 3 times dx. Allow it up. Times dx. So we will integrate it term by term. So here, by mentally simplifying this, since it has a square root, it sige, manual ko na lang. So it will become the integral of x minus 1. And then since we have the square root here, it will become 1 half. It will become raised to 1 half. So that is the rule. And then so by integrating it, 1 half will be added by 1. and then divide it by the overall number of exponent. So 1 half plus 1, we have 3 halves, like that. So we times it by 3 halves over 3 halves. Then here, since um, it has an square root and it is in the denominator, we'll put it in the numerator. So, uh, wait, before doing that, um, we will simplify this. We will, the square root sign, we will convert it into fraction. So this is 1 half. So putting a, um, when putting a number with the exponent will become negative. Putting when putting it in the numerator. So we have here x plus 2 and the exponent is negative 1 half, and integrating that, um, we will have, uh, we will add it by 1, so it will become 1 half, positive 1 half. So then divide it with the total number of um, exponent, which is also 1 half. Then next term, um, since it is negative, since it is x minus 3, it will simply become ln times x minus 3, then add our arbitrary constant. So we're gonna simplify this. So simplifying, we have 2/3 x minus 1, wait, wait, x minus 1, and then multiply it uh, by the exponent. And then the exponent is 3 halves. 3 halves, then adding it by 2. Since this is 1 half, when bringing it in the numerator, it will reciprocate, but to my term reciprocate, stack, and then it will become 2. Then copy the x plus 2, raise, wait, this is 2 raised to 1 half. Then copy the ln, x minus 3, and then the plus c. Uh, so, wait, dito. This is now your final answer for this. For our next topic, we will talk about the basic integration formulas under exponential function. So, by calling it from differential calculus, the derivative of e, oh wait, the derivative of e raised to bx. E here is our exponential function with respect to dx. And then in derivatives, this will be equal to b times e raised to b of x. So in integral calculus, we have the integral of e raised to bx times dx. So it will become e raised to bx over b plus c. So this is our formula for integration under exponential functions. So let us proceed to our example. For example number 1, we have the integral of e raised to 2x times dx. So according to our formula, we simply copy e raised to 2x, then over it by 2, which is our constant, and then plus our arbitrary constant. So this is your final answer. So in number 2, we have the integral of 1 over e raised to 3x. times dx. So here, we will put e in the numerator. So the exponent will become negative. So e here times e will raise by a negative exponent, which is negative 3x. And then we multiply it by dx. And then we will follow our formula, which is this. So copy e raised to 3x, and then we will divide it by our constant, which is negative 3. And then we will add our arbitrary constant. So this is your final answer. So in our next example, um, we have for our next example, so in our next example, we have the integral of square root of x minus 2 minus 1 over x plus 4 plus 10x times dx. So, call. So here we will integrate it by term. So the integral of square root of x minus 2. So according to our last topic, we will convert this square root sign into fraction, which is one half. So 1/2 plus 1 is equals to 3 halves. So copy negative 2 minus 2 become 3 halves. So diretsuhan ko na lang. So ang 3 halves here, kung nibatang mo sa numerator, siyempre divide mo niya sa 3 halves. Kung nibatang mo sa numerator, may ma-reciprocate. So mahimo ka 2/3. So this will become 2/3. This will become 2, wait. Become 2/3 x. Manit ko. So 2/3 x, tapos 2/3 x minus 2 raised to 3 halves. So next, since this is negative, so it is simply sa may logarithmic formula ta, ang formula ta, may mo, ang term na dya, may mo nga alaan, times the absolute value of x, which is x plus 4. Um, excuse. Um, then, the next term, since x ang anang exponent, this will become ln. So, become x, 10 raised to x, then copy. And then put ln of 10. Na, that. And then plus our arbitrary constant, which is c. So, this is now your final answer. So, in this topic, we will discuss about the basic integration formulas under trigonometric functions. So, we have here derivative of sine bx with respect to dx is equals to b cosine bx. So next we have the derivative of cosine bx with respect to dx is equals to negative b sine bx. Next we have tan bx. So the derivative of tan bx with respect to dx is equals to b secant squared bx. So next we have the derivative of cotangent bx with respect to dx is equals to negative b cosecant squared x dx. Next, we have the derivative of um, secant x bx with respect to dx is equals to b secant bx times tan bx. Next, we have the derivative of cosecant bx with respect to dx is equals to negative b cosecant bx times cotangent bx. So, in differential calculus, we have the trigonometric formulas that we have is, wait now, pangudod pala. Wait. Is the integral of sine bx times dx is equals to negative cosine bx over b plus c. And in the integral of cosine bx times dx, this will become sine bx over b plus c. Then in the integral of secant squared bx times dx, this will become tan bx over b plus c. And then in cosecant squared bx times dx, it will become negative cotangent bx over b plus c. And then we have in the integral of secant bx times tangent bx dx times dx is equals to secant bx over b plus c. Then lastly, we have the integral of cosecant bx times cotangent bx times dx is equals to negative cosecant bx over b plus c. So now we have um, I have introduced you our trigonometric formulas, um, both in differential calculus and in integral calculus. So take note, this is our trigonometric identities gali. So this is our trigonometric identities. So we will proceed now to our examples. We have in our example number one, um, we have we have wait lang. We have the integral of sine 3x minus cosine 4x plus secant squared squared times x over 2, and then put brackets, and then times it by d of x. So we will integrate it using our trigonometric identities. So the integral of sine is simply negative cosine. So this is 3x. So it will become negative cosine 3x and then divide it by our constant, which is 3. So, excuse. Um, so next, we will integrate negative cosine for x. So, sorry. So negative cosine for x is equals to negative sine. Wait, cosine. Cosine, the integral of cosine is equals to sine. So this will become negative sine, copy the constant, which is 4. Then, um, divided by 4. Then, next, we have the secant squared. So the integral of secant squared is tangent. So we have here tangent, uh, copy the constant, x over 2, and then divided by 1 half. Why 1 half? Because simply, um, our constant here is 1 half of x, 1 half x. So we put here 1 half, and then add our arbitrary constant, which is c. So that is not our final answer. We will simplify this. This will become 1/3, negative 1/3 cosine 3x. And then this will become 1/4, sakta 1/4 sine 4x. And then since since this is in the denominator, it will become 2 times the tangent, wait, times tangent, uh, tangent, without tagad lang, x over 2 plus c. So this is now your final answer for example number 1. So next, for example number 2, we have the integral of 1 half cosecant or sine. Oh, sige, cosecant. So this is 1 half cosecant squared the squared 2x. Then we'll add this um, plus secant squared. Ay, hindi na lang ako squared. Secant 3x. Talagi 3x times tangent of 3x what? Minus cosine 2x. Then times it by 3 by dx. So this now you're giving an example number 2. So first we will take out 1 half here since this is the constant. So 1 half, then um, the integral of cosecant squared is negative cotangent. So this will become negative cotangent 2x, ano naman, 2x, and then divided by 2. And then add it, the integral of secant times tangent will become secant, secant lang. It will become secant. Then copy 3x. So since 3 here is our constant, divided by 3. So, and then in the next term, the reciprocal, the integral of cosine is sine. So we put here sine 2x. Since 2 here is our constant, we'll divide it by 2. Then multiply, and then add our arbitrary constant, which is c. So we're gonna simplify this. So we have your 1 half times 1 half come to 1/4. Negative 1/4 perhaps kay negative cotangent 2x. So ari kita patang negative, ari kita patang 1. So this will become negative 1, negative 1/4. 1/4 times cotangent 2x. So next, since 1 di ang value sa babaw, so it will become 1/3 secant 3x. Next, since 1 ang yung value kay 1 half may mga negative 1 half sine 2x plus c. Correct me if I'm wrong. Charot. So this is your final answer. So next example. So here in our next example, we have ano ba? Mm, ano yung example? We have sine integral of sige try ito. Sine squared x dx. Since sine squared is wala sa atin nga trigonometric identities, mangita ta ibang pagid. So, according to our trigonometric identities, syempre cosine, here, cosine 2x is equals to 1 minus 2 sine 2x. So, we will derive our answer, our formula here, according to these trigonometric identities. So, in order to make this positive, i-transpose ta. So, matranspose ni kag-ari. So, it will become ma-positive ni. So, 2 sine 2x is equals to, ano din naman mo, minus 1, minus cosine 2x. So, since na may 2 sa may sine 2x, sine 2x, we will divide both sides by 2 para ma-cancel out. So, cancel, cancel. So, this will become sine 2x is equals to 1 minus cosine 2x over 2. So, now, we have our um, trigonometric identities derived from trigonometric identities. Actually, this is a double angle formula na yun sa trigonometric identities. So, we will use this. So, we will convert sine squared x into 1 minus cosine 2x over 2. So, this is what we will solve times the x gala. So, we will integrate it. So, uh, first, wait lang. First, we will separate 1 to 1 and cosine to x. So, it will become the integral of 1 half kay over 2 ni over 2 man separated by the negative sign. So, it will become minus. So, cosine 2x over 2 is simply 1 half cosine 2x times mo sa dx. So, alright. So, i-integrate na. So, the integral of 1 half is 1 half x. Simply 1 half x. So, and then, minus mo sa integral ka cosine, which is negative, integral ka cosine is sine. So, mas sine 2x lang sa 1 half sine 2x. So, ang sine 2x, kaya di ba over 2, ma-over 2 ka din. So, 1 half mo nga, i-times mo pa na yun sa may 1 half day. So, 1 half times 1 half is equals to 1/4. So, bali mo 1/4 ka lang pa. Yeah. Minus separated by a negative sign. Actually, itang gamay ko. Minus, wait lang gani. Sige lang. So, ano na lang ganyan? Negative 1/4 sine 2x. And then, add mo ang atin nga arbitrary constant since tapos na ta ka-integrate. Ano na ang atin nga final answer. So, in this topic, we will talk about the general integration formulas and the use substitution. So, our today's objective in this topic's objectives is to learn and apply syempre ang the different integration formulas and by using the use substitution. So first, our formula here first is um, the integral of u raised to n times du. So this will be equal to same lang sa may basic integration formula sa may algebraic functions. We have u raised to n plus 1 over n plus 1 and then add our c. Uh, so our n here is not equal to 1. So amo na ang ating first formula. Second formula is our sa logarithmic is our du over u. So according to our logarithmic formula, this will become ln u, absolute value of u, plus c. Amo na ang n natin is equals to negative 1. Negative 1 dili. Sorry, my bad. Then our third example, our third formula, I mean, is our exponential function. So, integral of e raised to u is equals to du times du gali. So, it will become a copy eu and then add our arbitrary constant, which is c. So, in the next formula, sa may, ano naman siya, sa may do mix, sa may au. So, we have here a raised to u times du is equals to au, copy au, over ln of u. ln of a gali, my bad, sorry. Then add our arbitrary constant. So, this is the four formulas that we will use during this topic. So now we will proceed to our examples. So for example number one, we have the integral of x times dx over x squared plus 4 raised to 2. So first, we will identify our u and our du. So ang u, makita mo na in usually sa denominator, sa sulod ka parenthesis or even sa exponent. So here, since our function here sa sulod ka parenthesis, so we will use that as our u. So our u is equals to x squared plus 4. And the du, which is the derivative of u, is simply 2x. So as you can see, we have now our u. This is our u, and we don't have our du, which is 2x. So we have here x. So we will add 2 there. So it will become 2x dx over x squared plus 4 squared. So we have now our u and du. But since naging batangan mo gitig 2, may rule na once may ginbatangan ko din 2, mabatang ka man gi 1 half to balance it. Kaya syempre 2 times 1 half is equals to 1. So amo na. So proceed. So 1 half. Then distribute the value of u and du. So this is our du over u. Integral na. Integral u squared. Wait. So, lot. So, according sa atong formula kaina, um, 1 half du, 1 half times the integral of du over u is equals to, wait, before ka mag-integrate gali, since our u here is my exponent, we will put it in our denominator. So 1 half. So it will become negative u raised to negative 2 du. So when we integrate it, it will become uh, wait, ikat ko lang muna. Um, So since uh, are you here? Dumaan ang tagal. Differentiate. So we will add 1 to the exponent. It will become u raised to negative 1 over negative 1. Um, and then add our arbitrary constant, which is c. So copy 1 half. Simplifying this, it will become 1 half times 1 over u, then our arbitrary constant, which is c. So we will distribute now our u. So 1 half 1 over ru, which is x squared plus 4. Then add rc. And then this is your final answer for problem number for example number 1. So now we will proceed to our example number 2. So this is the given for our example number 2. So this is the integral of x plus 1 times dx over the square root of x squared plus 2x minus 4. So first we will need to identify our u. So I choose ru um, inside the square root sign. So this equals to x squared, wait, x squared plus 2x minus 4. So the derivative of x squared plus 2x minus 4 is 2x plus 2 times it to dx. So here, you can manipulate it by factoring it out to get para magpatas sa may x plus 1. So we will distribute, we will factor out 2. So put here 2 times x plus 1 dx. So now we have our du and ru. So as you can see, butang ka lang take 2 here. So when magbutang ka dito, butang ka 1 half. So put mo 1 half diya, tapos 2 x plus 1 dx over with integral na square root of x squared plus 2x minus 4. So we have now our u and our du. So distribute u and our du. So this is 1 half times the integral of du over u. Simplify mo, ay convert mo ang square root sign to 1 half. So tama lang ni raise u raised to 1 half. Tama na. So next, i Sailon ang u sa babaw. We'll put u in our numerator. So copy 1 half. So u here will become negative. So become u times raised to negative 1 half du. Integral galit. So next, we will integrate. So 1 half integral of negative 1 half is u raised to negative 1 half plus 1 will become 1 half. So u 1 half plus c. And then since 1 half over 1 half, may mga na mga 2. 2. So come 2 here. So ma-cancel out ni. So it will become u is to 1 half plus c na lang ang within. So distribute the value of u. So tapos pwede mo man mabalik sa ang 1 half, pwede mo mabalik sa square root sign. So ru here is x squared plus 2x minus 4 plus c. So pwede mo ma-convert balik ang square root sign. So pwede man hindi. Depende kung multiple choice, may choices na kung gusto mo yung 1 half cab or gusto mo i-convert sa root. So this is your final answer. So we'll proceed to example number 3. So in example number 3, we have integral of x cubed, the x cubed plus 3. And then times x squared, I mean 3x squared. I mean x squared na pala. X squared dx. So now, um, so now we will apply the u substitution. So our u here is inside the parentheses, meaning this is x cubed plus 3. So our du, the derivative of u, is 3x squared. So we are missing here 3. So put mo kayo 1/3. Tapos, ano ko na lang, sige lang, 1/3 copy 3 cube plus 3 integral sign 3x squared. Now we have our u and our du. So this will become 1/3 times the integral of our u du. So um, next is we integrate u. So the integral of u is simply u squared over 2. So it will become 1 half. So 1/3 times 1 half, and then 1/3 times 1 half, u squared plus c. So 1/3 times 1 half become 1/6. And then we distribute the value of u, right? Which is x cubed plus 3 squared. And then add our um, constant. So this is your answer and example number 3. In this topic, we will discuss about the integration by parts. So, what are our objectives? So, simply, our objectives is to understand and apply the techniques of integration by parts, and its formula. So, um, our formula for integration by parts is um, d times uv is equals to u times dv. Amo ni i-derive mo natin ulit sa sa integral. So, u dv, amo ni ang formula sa differentiation v du. So, we will integrate both sides. So, it will become the integral of u dv is equals to the integral of d times uv muna minus the integral of v du, like that. So simplify, we have the integral of u dv is equals to uv, kaya makancel out ni, minus the integral of v du. So this is our general formula for this topic. So we will head to our first example. So first, our first example here is the integral of ln x dx. So by using um, the formula, we will find first our u. So u is, let's say, ln x. And the derivative of ln x is dx over x. This is also 1 over x dx. So then we need to find our dv. So our dv here is um, dx. Right, sakto. dv. Ito ba daw? dv. So dv here is dx. So our v is x. Balis ka M lang. Opposite of integration is differentiation. So next, we have our u and our v. We have our u, du, dv, and v. So we will distribute it according to our. We will first um, use it in our formula. So this will become u v minus the integral of v d u. So next, we will ano ganito, um, substitute. We will substitute it to our formula. So this will become x times ln minus the um, integral, the integral of x times dx over x. Uh, yeah, so x over x. Yeah. So simplifying this, copy ln x and then minus it by dx. So this will become x ln x minus x and then you add our arbitrary constant which is c. So now you have your final answer. So in our next example we have um let's go trigonometry. So we have here second cube theta. We will use theta and then d theta. So now we will identify our um wait okay. So now we have our given and then next um we will identify our u and our v, our u and v's, our u's and v's pala. So our u here is second theta and our du here okay sila first kili first we will ano ganito factor out second in order to use trigonometric identities. So by factoring out, this will become the second theta times second squared theta d theta. Now we can use our um, integration by parts formula. Now we have here u. So our u here is second theta and our du is equal to the derivative of second theta is second theta times tangent theta. Then multiply it by d theta. And our v here, emit dv gali, stick to our formula. And our dv here is second squared theta. Second squared theta d theta. And then the integral of second squared theta is tangent theta. Like that. So now we have our u, du, dv, and our v. Now we will distribute it in our formula. So this is our formula, and distribute it. Then this will become secant theta times tangent theta minus the integral of tangent squared theta. So secant theta times d theta. Yes. Next we will um squared, yeah. We will apply our trigonometric uh identities. Become secant theta times tan theta minus the integral of by using trigonometric identities. This will become secant squared theta minus 1. Then copy secant theta d theta. So now um, we will combine it. So here, wait, yes. So now we will, in order to solve this, we will copy the given first. Copy secant theta, secant cube theta d theta. Then copy this secant theta tan theta minus secant secant uh, this will become cube now. Sakta come cube theta d theta times it by secant multiply gali add gali secant theta d theta. uh, right. So next, uh, since we have both um graph of theta integral of theta raised to cube raised to 3 here, we will put 2 here like that kasi duwasan da. So kaya tapos negative kung i-transpose mo sa payak ma-positive. So become 2 secant cube theta d theta is equals to copy secant theta times tangent theta and then add mo ang nabilin, which is ln, wait lang, wala ka, ln, integral of ln secant, absolute value of secant theta tangent pala times tangent theta plus c. Now para ito ang final answer. Next, since ma 1 half dya kay 2, sakta. So we'll put 1 half here. Kay i-divide mo na sa 2 mo. Divide mo na sa 2. Divide mo na sa 2. Cancel out. Cancel out. So, ma 1 half dya sa 2 bang. So, put 1 half here. Then copy secant theta tangent theta. Then add it to ln secant theta. Hindi ko Wait. Edit. Wait lang. Wait. Ay, butang. Nice one. So this will become to the final answer 1/2 times secant theta times tangent theta plus the ln of the absolute value x, which is secant theta plus tan theta plus c. So now, this is your final answer for number 2. Next, we will proceed to number 3. So, um, so next, we will have our example number 3. So the given is x times sine x dx is equals to, so first we will wait lang, we'll we will find ru. So ru here is x and our du is dx. Parang ay gagi ko. Is equals to dx and our dv here is sine x. Then our v here is negative cosine x. So we have our values of u, du, dv, and v. Next, we will apply this in our formula. So this will become negative x times cosine x minus the integral of negative cosine x dx is equals to negative x cosine x plus the integral of cosine x times dx. So now, by simplifying this, we have your answer. It's equal to negative, allowable, negative x cos x, shumay, ano man, cosine x plus sine x plus c. So this is now your final answer for this um, example. So thank you everyone for listening.